Alrighty, so this is the other lesson in 10.2, um, looking at the difference in mean. So we looked at mean difference, and now this is the difference in mean. So here we go. There's a difference in the number of chocolate chip cookies in Chips Ahoy versus the brand named ones from Meyer. Each of 28 students counted the number of chocolate chip cookies in one Chips Ahoy cookie and one Meyer cookie. Due to the factory's processes, we can assume that the population distribution and number of chips are approximately normal, and the samples are random. So we are given some information here. We're going to let mu1 equal the true mean number of cookies in Chips Ahoy cookies, and mu2 be the number in Meyer cookies. Um, so this is kind of going to our state phase right here. A couple other things we need in our state is what we're actually going to find is mu1 minus mu2. We're going to do a confidence level, let's say 95%. And there we go. Oh, and then we could also get our x bar and x bar 1 minus x bar 2. So we are just given the data here instead of actually doing this activity. So some information here about the sample. So x bar 1 minus x bar 2, that would be 21.56 minus 18.22. That subtraction should be 3.34. I'm just going to pull my calculator up and have it up on the side here. Okay, so that is my sample proportion. So right now we can see that x1 is bigger than x2, which means that Chips Ahoy does have more chocolate chips than Meyer for this set of samples here, but we'll see in the future. Um, Important to realize that this is a difference in means. We are going to do mean 1 minus mean 2, which means this is two sample data, which is different than that one sample pair data that we talked about. So we actually have two different samples. All right, there's no reason to pair them up. There's no reason to think that like this one Chips Ahoy cookie that a kid randomly gets and the one cookie from Meyer has anything in relation to each other. There's no reason to pair it up. So we do actually treat this as two separate samples. All right. So moving on. Let's see. This is not super important. Because it'll come up. We'll skip through. It'll just come up as we come to it. So, have the conditions for constructing a confidence interval been met? Explain. So, first condition is random. And since it is two sample, we need to check both. So, random samples of both brands of cookie. Okay. So that's the first thing. On the 10% condition, so we sample 28 from both. So 28 is less than 1/10 of Chips Ahoy. Call it Chips Ahoy cookie. And 28 is less than 1/10 all Meyer cookies. So the 10% condition is good. And then lastly, the large count, I'm kind of put it up here just so it fits. Remember, there's a hierarchy we go through. The first thing we have to check is, are the populations approximately normal? And they are. So we're done. We don't even have to check the large counts or anything like that. We are satisfied. So Both population distributions are approximately normal. Right? And the key thing is both population distributions. They're both approximately normal. So again, you got to check it for both samples. Okay. So we're now going to construct the interval. This should be fairly self-explanatory. So we're going to have our x bar 1 minus x bar 2 plus or minus t star. And now we got to combine them, right? So if one of the standard deviations was s sub x over square root n, when I add random variables together, I need to add the variances, right? So this is standard deviation. That means that my variance is that. So I'm going to have the new variance of the two, so variance of x bar 1 minus x bar 2. Right, that would be sx1 squared over n1 plus sx2 squared over n2. Because of that, that's the variance. To get the standard deviation, then I will just take the square root to get the standard deviation. So that is what I have here. Okay, again, it's just only the s is squared because that n is really the square root of n. That gets squared to just become n. So here we go. We're going to get 3.34 plus minus. We'll skip t star for a second. Uh, 2.49 over 28 plus 4.51. Now to get that t star, if I do in the calculator, so I want a 95%er. So that means that 0.025 is in both sides. I'm going to second do inverse t 0.025. My degrees of freedom is going to be 27. You do need to write your df on an FRQ problem, what it is, because depending on what your degrees of freedom is, things are going to change a little bit. So 2.0518. So I'm not going to take that, and I'm going to now this times that by -1 for now. And I'm going to store in x. Okay, I'm going to get my standard deviation now. So 2.49 squared divided by 28. Plus 4.51 squared divided by 28. So let's add together. Take the square root times it by x. That gets me my margin of error. I'll store that as alpha m for margin of error. So I'm now going to do 3.34 plus m. 3.34 minus m. So my my interval goes from 1.34 to 5.34. So we'll come to 6. Let's go ahead and just write this in first. So so we're 9% confident that the interval from 1.34 to 5.34 captures the true difference in means for Chips Ahoy cookies minus Meyer cookies. And you probably should say like mean number of chips. That's how you interpret it. So it is the true difference in means, because you had two different means and you found this subtraction, the difference in or of two different means here. So then it asks, do we have evidence to suggest that the average number of cookies in the Chips Ahoy is in Meyer, or which one's greater? Since this is all positive, right, this goes back to that same idea we talked about earlier in the year. Plus plus, convincing for population 1. Minus minus for population 2. And minus plus tells us nothing. Okay. Or is not convincing, because it could be either one. All right. So, real quickly, just to wrap up, I want to show you how to do this in the calculator also. If you do a little bit faster, because it's going to change your answer slightly. So, stat over to test. This is now a 2 sample t interval. 2 sample t interval. So I know the statistics. X1 is 21.5. Okay, I guess it didn't like that. 21.56. 2.49 and 28. Next one is 18.22. 4.51 and 28. We want a 95. The pooled will just say no. Keep it no always, and then press enter. And you'll notice this interval is a little bit different. It goes 1.37 to 5.3. Really 1.38 to 5.3. Oh, the reason is, if you look, they have a degrees of freedom of 42. All right. There is a way to calculate the degrees of freedom that the calculator can calculate. And so they have a really specific formula. It's really long and messy. Only the calculator will do it. But because of it, it's a little bit more precise. they give a little bit smaller of an interval than what we did. Our interval is still sufficient, but just know that if you go to use your calculator to check it, the degrees of freedom is a little bit different. So if you're ever going to, you need to make sure you're using degrees of freedom from calc. Degrees of freedom equals 42.06. Yeah. For us, on the other hand, right, in addition to this, talking about how we get our degrees of freedom, because there's two ways. We always want to be more conservative. So you choose the smaller sample size and then do n minus 1 for the smaller sample. In this case, they were both 28, so it didn't really matter. But usually, we want to be the most conservative as possible, so you'll just use the smallest one. Like I said, the calculator can do it, and so they can have it be a little more precise, but either one is fine. And then obviously, as you're filling out the notes here on the next page, this is really important. Check for each population. And then in the do phase also, again, like I said, the other big thing that people forget, you got to write degrees of freedom. Because again, depending on what you choose is a little bit different. And again, if you have the T table, you have to use your actual calculator or the table to find it. You might have to change it also, right? Like ours was 27, which worked out, but say our degrees of freedom was like 32. If you have to use the T table, you have to use an even different one. So you just want to keep that in mind. All righty.